In this video, we're going to do another example of finding the resultant force and the resultant moment. So we have a platform here that looks like this, and on this platform we have three different forces here. Okay, so this 5 kilonewton force, this 2 kilonewton force, and this 3 kilonewton force. And what we're asked to do is we're supposed to find the resultant force and also the resultant couple moment at point O here. And we know that the resultant force is equal to the sum of forces, and that the resultant moment about point O is equal to the sum of R cross F. So to solve this problem here, what we're going to do is we're going to start by doing the sum of forces first. We're going to find the resultant force first. Okay, so let's do that now. Sum of forces. Okay, and then what we're going to do now is we're going to get the sum in the x component. We're going to do the x component, and then we're going to do the y component after. So what we get is the sum of forces, okay, or so the resultant force in the x direction is equal to the sum of forces in the x direction. As always, we're going to define our positive. So we're going to define this, like you're going to find right as our positive, so left to right as positive. And again, you can define any direction as positive as long as you stay consistent in the calculations. So, as you can see here, let's start with this 5 kilonewton force here. What we're going to do is we're going to get the x component of this force. And so to do this, we just multiply 5. Okay, so 5 newtons times this ratio here, so 4 divided by 5. Okay. And of course this will be positive because it has a right direction, the force points right. Okay, how about this 2 kilonewton force here? Well, as you can see, it does not have an x component, so this would just be, the x component of this would just be 0, and we would move on here to this 3 Newton component here, or this 3 kilonewton component. And in order to get the x component, we would just multiply 3 kilonewtons times 5 over 13. Okay, and since this has a left, it points right to left, okay, it points in the negative x direction, we would define the direction as negative. And so we go 3, by the way, this should be kilonewtons. Kilonewtons. So 3 kilonewtons times 5 over 13. Okay, and then when we sum this up, we get 2.85 kilonewtons. So that's the first step there. And then what we're going to do is we're going to do the sum of forces in the y direction. So we're going to get the resultant force in the y direction, which equals to the sum of forces in the y direction. As always, we're going to define which way is positive. I'm going to say the positive y-axis is positive for convenience. And then we'll go ahead and sum up our, I'm going to sum up our forces here. So as you can see here, all three of these forces point downwards, so they're all going to be negative. So we'll start with this force here, the 5 kilonewton force. Well, what is the y component of the 5 kilonewton force here? Well, as you can see, it's 3. So what we're going to do is we're going to multiply 5 kilonewtons times 3 divided by 5. So 5 kilonewtons times 3 over 5 minus, and as you can see here, this force is completely vertical. There is no x component, which means the y component is just going to be equal to 2 kilonewtons. 2 kilonewtons minus, okay, this is also going to be minus because this force points downwards too. Okay, and then what is the y component of this force? Well, we just multiply 3 by the ratio of 12 and 13, right? The y component and the hypotenuse here. So it's going to be 3 kilonewtons times 12 over 13. And so when we punch all that into our calculator, you would get the following: negative 7.77 kilonewtons. Okay, so then if we want to write our total force, if we want to write our resultant force, we can write it in two ways. We can write it in Cartesian vector form, which would be Fr, and what we do here is we just write the different components individually, which is a nice convenient way of expressing a vector. So we would write 2.85, so that'd be the x component here, and we put an I right beside it, and then we go minus 7.7 j. Okay, j is for the y component, and then we would write kilonewtons. Okay, so this is Cartesian vector. Okay, and also we can write our answer as a magnitude and an angle. And so magnitude and angle. And so the magnitude of Fr, okay, magnitude of Fr, of our resultant force, is equal to, we'll just do the Pythagorean theorem on there, which is going to be the square root of 2.85 squared plus negative 7.77 squared. That's going to be in kilonewtons. And when you put that into your calculator, we get this. We get 8.27 kilonewtons. All right, and then the next thing we have to find is the angle, okay, which is theta. So if you look at it this way, okay, so we have the x component, which goes like that, and then the y component goes down like so. Okay, now depending on which angle you want, we'll use this angle here. So if this is 2.85 and this is negative 7.77, what this means is that this angle, or this side here, is going to be the opposite, and this side here is going to be the adjacent. So to get this angle, we're going to go tan, okay, the arctangent of negative 7.77 over negative 7.77 over 2.85. Okay, this should be a 5, not a 3. Okay, and the angle we get is negative 69.9. 69.9 degrees. Okay, and then we would just indicate it, which angle we're talking about, by writing it in this form here. So the next step, we're going to calculate the sum of moments. So we just scroll down here a little bit, and then we'll do the sum of moments. So we go sum of moments of moments. Okay, and so for a sum of moments, we know that the resultant moment about point O, the origin, okay, and point O being here, is that the sum of moments around that point is equal to 0. Or sorry, is equal to the sum of moments. Excuse me. So the resultant moment is equal to the sum of moments. And of course, what we're going to do is we're also going to define which direction is positive. Again, in this case, what I'm going to do is I'm going to choose counterclockwise. Okay, so counterclockwise is positive in this example. Okay, so let us start going through the different components of the different forces to sum up our moments. So to start off, we'll start with this 5 kilonewton force here. And what we're going to do is we're going to consider the vertical component first. So the vertical component, as you know, the moment is equal to the force times its perpendicular distance. So what we are looking for here is this component of the force times the perpendicular distance from O, which is going to be this distance here. Okay, let me just make that a little bit. Okay, so this component of the 5 kilonewton force times this distance here, in which case it's going to be 4 meters. So we're going to go 5 kilonewtons times 3 over 5 times 4 meters. 4 meters. And as you can see, this is going to be positive because it will have a counterclockwise rotating tendency. Okay, so this 5 kilonewton force causes a counterclockwise rotating tendency. Just gonna move this out of the way here. Okay. Now let's consider the horizontal component of this force. Okay, so what we have here is this component of the 5 kilonewton force times the perpendicular distance, okay, which would be this distance here. Okay, so this force times this perpendicular distance. And as you can see, the perpendicular distance is 5 meters, so that is what we are going to multiply it by. Okay, and what you'll also notice is that this horizontal component points this way, which causes a clockwise rotating tendency, so therefore it will be negative. So we have 5 kilonewtons times 4 over 5 times its perpendicular distance, 5 meters. Okay, so that's it for this force here. Let's go on to this one. Well, luckily we were only dealing with one component here. There is no horizontal component, so we're just dealing with this vertical component of the 2 kilonewton force. As you can see here, it's going to be this 2 kilonewton force times the perpendicular distance from O, which is this right here. Okay, so this distance times this force. As you can see, this distance is 1 meter. So what we're going to end up with, and also one thing to note too, is that this causes a counterclockwise rotating tendency, or sorry, clockwise rotating tendency. So therefore, it will be a negative moment. So we'll go 2 kilonewtons times 1 meter. And that's that for that force. Okay, let's move on to this force here, the 3 kilonewton force. So let us start off by considering the vertical component of the force. As you can see here, it points downward. Okay, this force points downward. Okay, so we're multiplying this component of the 3 kilonewton force times its perpendicular distance from O, which will be this distance here. As you can see, this distance is 2 meters. And since this component is on the right side of O and it points downwards, is going to cause a clockwise rotating tendency, which means it's going to be negative. So we write minus 3 kilonewtons times 12 over 13, okay, 12 over 13, times the perpendicular distance, which is 2 meters. Okay, and then the last thing we're going to do is going to consider the horizontal component of this force here. Okay, so what we're looking to do is we're going to multiply the horizontal component of this force, okay, which is this right here, okay, times the perpendicular distance from O, which will be that. Okay, so the perpendicular distance is going to be 5 meters, and the horizontal component of the force is going to be 3 kilonewtons times this 5 here divided by the 13. And since it points this way like that, okay, it causes a counterclockwise rotating tendency. So therefore, our moment will be positive. So we'll write plus, this time, 3 kilonewtons times 5 over 13 multiplied by this perpendicular distance here, which is 5 meters. And so that's all the different forces accounted for. So what we do now is we put this into our calculator, and when we do that, we get this. We get negative 9.77 kilonewton meters. Okay, and it's going to be clockwise. And there you have it. So that'll be this answer here, because that is the answer for the resultant moment. And then up here, the resultant force, this would be the answer here.